So we're going to talk about tracing now, and it's really important because as our application gets more complicated, we need to figure out our bugs and errors and fix those issues. But before getting into any complicated techniques, we're going to talk about the first debugging method called tracing. And tracing is one of the oldest, or probably the oldest method of finding out where our issue is, and that's basically leaving a little pebble at every step of the way. So as if you were going in a forest and you're wondering which direction did I take, you would leave a little pebble and then you could retrace your steps to see what happened. So like this, you could figure out, oh, I should have turned left when I turned right, as an example. So how would that work inside our programming is by basically doing prints. So if you look at over here right now, I have a little application that's basically doing the factorial. It's basically this little symbol over here if you did math. If you haven't, it's basically itself multiplied every other number until it reaches 1. So as an example, if we have, let's say 5 factorial, we're talking about basically 5 multiplied 4 multiplied 3 multiplied 2 multiplied 1. All right, not multiplied 0 because then it's meaningless, right? It's all 0. So over here, this is what a factorial of 5 means, 5 factorial. So I created a code here to make it work. And right now, our current n, in this case was 5, our current n over here is 20. So basically we're doing 20 factorial, which is 20 times 19, 18, 17, blah, blah, blah. So if we run it, we'll notice that we're getting an issue. The factorial of 20 is minus. What's going on here? And again, we talked about integer. Well, we talked about overflow, and this is probably it. But for us to figure this problem out, we first have to go on a reliable source. Let's say as an example, I'm going to grab over here, I'm going to grab Google, and I'm going to say 20 factorial, and I'm going to press enter. So you could see over here, 20x factorial should have started with 2.43 and obviously not negative. So it's for sure that we're wrong. I'm going to leave this here for now. I'm going to come back to it in a little bit. So how can we figure out what the error is? Well, the best way is to figure out what the value of our factorial is at every step of this multiplication, right? So there's many ways. For now, we're going to talk about tracing. And tracing is pretty easy. So what I'm interested in is this factorial times I. So important part. So right after this part, I would like to put a little system.out.println. And there are different outputs that you could utilize, such as I think it's ER. It's up to you which one you utilize. For real, it doesn't make a difference at this level. Okay. This is just outputting rather than to the console. It's outputting to the error area. We'll talk about it in the future. So I want to note what's the value of a couple things, the values of things that matter in my code. And in this case, I want to see what the value of I is currently, because that's this multiplication that's going on. So I'm going to say I, colon, space, and concatenate it with the variable I. I also want to know the value of my factorial, right? At every step. Remember, this is a loop. So every step I gets bigger, factorial gets multiplied I. So here I'm going to write factorial, and we're going to see the current level or the current value of factorial. Any other values we want? Well, n, we don't really care. That's just my limit. It's not going to change, so I don't need to put it. You could if you want to. I think, but this is good. So we're saying starting at 1, we're going 1, 2, 3 times every number until we reach n. We want to see what the value of our factorial is. So if I press run now, you'll notice my console is going to get full. And mind you, it's red because we're using the system.err. So over here, we started off 1 is perfect. 1 times 1, that's the initial value, is perfect. Then 1 becomes 2, so 2 times 1, it becomes 2, obviously. Then it would be 2 times 3. You know, we can make this a bit maybe even more cleaner. I don't know. Let's bring this up here, and we could say, rather than I is this, we could say I, well, we could say that, plus, let's say multiplied, and over here we'll put our factorial value, factorial, plus, and we're going to say that's our f for factorial, just to make it a bit clean. Let's run it again. Again, tracing is up to you. It's just a way for me to see what the values are. So initially we do, actually let's put a little colon right after. It looks nicer like that. I am a little bit of a, anyway. So here we got 1 times 1, which give me a value of 1. Then we got 2 times 1, which give me a value of 2. Then we got 3 times 2, which give me a value of 6. 4 times 6, 24, seems correct. 5, 24, 120. Right? And at any moments that we believe that this doesn't match, we could always take out our calculator. 6 times 120, 720, sounds about right. 7 times 720, sounds still good. It's pretty good. Again, we could double check all these values, but you could see our iteration as it going higher and higher. Our factorial value is becoming much bigger. And it seems to be going good. Again, if we need to, we could check out what is the max integer value we have, right? We've seen it in previous videos. But for now, we're just going to go down until, look at over here what happens at factorial 17. The moment I'm multiplying 17 times, how many zeros is there? Let's say that's 1,000, 1,000,000, 2 billion. So the moment I'm doing 17 times 2 billion, well, here we got a integer overflow, and we're going back to negative, right? We could see that this is reaching our max value. So again, we're going to copy that. We're going to put it here, just so I remember that this was the value, and we multiplied it by 17. Well, again, if we need to make sure that this gives the correct value, we go here, we do this, we press enter. Should have gave us 1,000 here, 1,000,000, 1,000,000,000, 34 billion. Now, what is my maximum of integer? That could be the problem. Again, I said it multiple times, but we're trying to debug this step by step logically as much as we can. So here, we put our max integer as an example. And to get the maximum integer, we're going to use the capital N, the capital I, get integer dot, and we're going to get max value, right? Already just putting your mouse over it, this is this value should be shown to you. Sorry, this is a final value. We'll come back to that later, but notice that here we got 1,000, 1,000,000, 1,000,000,000. 2 billion was the maximum number. Notice over here, we're at 2 billion. We're just missing 100 million-ish. So we reach the maximum value that we could do 2 to the power of 31 minus 1. So the moment it went 17 times this, well, our integer is overflowing. It's not enough for what we need. So what we need to do is to go at the next size. And it's easy for us because we know long is double the size, right? We could actually erase all of this. And now if we run it again, you'll notice that we got a new value, 24329. So if we do back here, notice 20 factorial, sorry, we got 2.43 to the power of whatever. So this is actually the correct number, 24329. 24329. So you can see we have the full number here. So we fixed our error. Now, one last important part about tracing is this trace that I left here. This was to help me program. Our user doesn't require to see all of this uselessness. It's a lot of junk in their face. So last thing to do and this is probably why tracing is not utilized so much, is to ensure that we remove any type of tracing that we did either with the out or with the ERR. Eventually, we'll learn about how to put these tracing into a different place so that even if we leave it in the code, the user never sees them. But for now, we got to get ourselves in a habit of removing these non-required code that allows us to trace our code and to understand what the problem is. And even better than that, also remove any comments that are a bit meaningless. All right. Remember that we want to try and get a clean code, so too much of anything is pretty much bad. Thanks, guys. I'll see you in the next video.